this particular stage and how I involve with uh, startup company and also one of my business partner right now in the Turing Point, Dr. Tirthankar Raychaudhari. So just give you a bit of my when I passed out in 1998, and I was trying to prepare my GMAT and MBA for a GRE to go to the US actually. And I didn't know that I was landing to be in Australia, you know. But I applied for a couple of universities. Luckily, I got a scholarship for my master's from Charleston University. The campus was in New South Wales, which is the New South Wales quite big. It's bigger than actually, probably quite bigger than your West Bengal. I can, if you can imagine that, yeah. So I did my majors in masters, especially in information superhighway at that time. And lately, my project was at that time is an e-commerce solution. And there's another part I did was a GIS, which is a geographic information systems in my major actually. And after completion my masters, then I started very small, like, I looking for how can I go to the actually Australia market in the technology job opportunity. So it was a very difficult time at that time. I can imagine like 21 years ago, the IT market was is booming, but at the same time, the Australia just opened their door, at that time. And I had a very memorable time when I was a part of the Sydney Olympic. It's my lifetime achievement. I was working for IBM venue IT officer for that part of my project assignment at that time. So it gave me bit of lead and global exposure into the global, organizations to get into the job market at that time. And luckily, I step into one of the global financial institute. It's a Canadian bank called Toronto Dominion as a data analyst at that time. And from there, I work in Hewlett Packard, but to the vendor site, which is a distribution channel, global company called Cinex Technology. I was a product list. And after that, I've joined Sydney Train and it's been there for nearly 10 years. Actually, this month, 7th, it's 10 years anniversary. And in the Sydney Train, I had a couple of new role. The present role is my configuration management coordinator. The mainly I take care of all the project change, which is the transport cluster base. And when I say is a fixed asset, not the software configuration change. The fixed asset means it's a rolling stock, and whenever you introducing new assets to our network inside, that means it go to my board. It's called configuration management control board actually, and after that, in the meantime, I've done two diploma from University of New England. My diploma in project management and also diploma in management at the same time. So in 2018, actually, I was thinking, so far, I always had a dream to do something innovative in always when I was studying in RSA Durgapur. So I had an opportunity to establish and found one of my first company in Australia, which is Bluebell Research Australia. Um, that company, we have two main like a component, and we focus two services mainly. One is the e-commerce solution, and the other one is a digitization and digital marketing for Australia market especially. And then after that, there's another product opportunity beta versions already been designed. We're hopefully will go to the commercial market very soon. That process also going on at the same time. And the third one, how I involved in the Turing Point, and that's why is Dr. Tirthankar Raychaudhari also today here. Currently, there's a New South Wales government. They adopt one of the technology which is called European Train Control Systems 5 years ago. That European train control systems, it's been converted to the New South Wales train, which called ATP, Automatic Train Protection. Actually, it has two components. There's two function basically. One is a sailing speed supervision. Other one is your brake to target supervision. So these two the function mainly driven by AI, artificial intelligence, and we are in phase 3 right now. But the New South Wales network is quite big. It's bigger than England network right now. And so it's a very vigorous process. We're in phase 3, and it's going to be up to phase 8. So these two particular main functionality, the first one, the sailing speed supervision, actually prevent train travel over the speed limit. So what it does, it has the driver when the sitting on the compartment of the train has a sensor underneath, and at the same time the track in the has the ballast. The ballast has the sensor as well. So when the speed, the train drivers sometimes they oversee the speed limit of 40 kilometer in certain limitation of the speed, then before they approach to the second station, automatically the signal goes to our control systems. So from the control systems, then the controller take control of the train driver and then automatically block to the brake, and it slowly slow down before approach to the station. And the brake to target supervision is also a safety, your acceleration of safe acceleration of the train and operating, especially for your rail worker side. Well, of course, in India also has that. There's positions going on every weekend position. When the workers go to the site, for the safe of the worker, we have that signal and sensor been embedded in the ballast on the track. So before the train approach to that particular work site, automatically the alert signal goes to all the individual work, the vest. It has the beep noise. That means the worker knows that the train approaching towards in the work site. So this is the things which is drive me to actually involve with Dr. Tirthankar Ray, and he the founder of the Turing Point. So I taking this opportunity, and again thank you to Dr. Shivendu Shekhar Roy and all the alumni today who's listening to our this conversation and our discussion. I think I must and now hand over to Dr. Tirthankar Roy for give you all AI matter of the industry base. We have some case study also he would like to explain to you all. If you have any questions, you can ask after our presentation. Thank you. I hand over to Dr. Tirthankar Raychaudhari now.
Thank you so much, Arup, and greetings, everyone. It's Dr. Shivendu and members of the audience, friends. Just a few words of introduction about myself, and then we'll talk a bit about Turing Point and the kind of exciting AI stuff that we are into and where we see ourselves going in future. All right, so my name is Tirthankar Raychaudhari. I am originally from Kolkata. I was born in Kolkata, and I graduated in electrical engineering, not from NIT Durgapur, but from Jadavpur University. And I also did a master's from there. I worked in India for quite a few years before emigrating to Australia, and I've now lived in Sydney for 30 years. So it's been a while. Before COVID happened, I usually travel back to India, once. I'd like to do it every once a year, but on an average, I've been averaging every, uh, 2 years. I go back to, home and roots, which is Kolkata. I don't believe I've ever had the pleasure of going to Durgapur. Maybe I'll go there someday. But my roots are very much from West Bengal, and that is my heritage. That is how I would identify myself. Although I've been a Sydney sider for a very long time. Now, uh, I actually have never actually worked as an electrical engineer. The work I did in the 80s, when working in India, was more in industrial electronics. And from there, the transition to the IT was a natural progression with people of my background at that time. So, yeah, electronics, microprocessors, instrumentation, and then moving across to IT. So, the last job that I had in India before I emigrated to Sydney, I used to work for an organization. I don't know if any of you would know it or remember it. They were called CMC Limited. So that was a government of India public sector enterprise, and it was basically founded when India had the last Janata government, not the current BJP, but when India had the first, if people remember, when Morarji Desai was the first Janata Prime Minister. They made several policy changes at that time in India, and IBM Corporation were not allowed to operate in India anymore. So all the IBM machines and mainframes at that time, there used to be a lot of mainframes. They were taken over by the government of India. They formed an organization with very, very advanced skill sets, sent people, to the US, to European countries, got them trained, and we were a very advanced thinking organization. So that was my last job when I left India. So that's a bit of my background. But I really did not have formal degrees and training in computer science. After arriving in Sydney, I worked for a couple of years for a small IT organization. They were more into hardware and networking, and organization called Emperor Systems. They don't exist anymore, but things were very hard at that time. There was a global recession happening across the world. People were, companies were laying off people. The industry was not, there was no growth or anything at that time. Although I was here in Australia, I arrived as a permanent resident. I've been a citizen of Australia now for 28 years, but I thought that would be a good opportunity for me to go back to university and study. And my background in electronics, and I have active interest in control theory, I ended up doing a PhD. So the university I did my doctorate from, it's called Macquarie University, Lachlan Macquarie, named after the first Governor General of Australia. He is credited to be the man who transformed Australia from a British convict settlement into an actual country and a republic. It's named in his honor. We have a lot of institutions in Australia named after Lachlan Macquarie, a Scotsman. So that, I mean, we have Macquarie University, Macquarie Bank, and various other institutions named after Macquarie. So that Macquarie University is located in Sydney. Sydney is an enormously large city. If I don't know if any of you have traveled here, been to this part of the world. Although Australia is a small country, only 23 million people, but about I would say, about 1/5 of our population lives in Sydney. So Sydney is, if any of you have been to the US or to LA, it's about the size of LA. And there's a lot happening over here. It's a very vibrant place. We are on the harbour. We have about 20 beaches. We've got a harbour bridge. We've got an opera house. It's a very beautiful part of the world with very shall I say, very, very temperate climate. It's winter now, but, we don't get snow or anything. Winter, it probably gets as cold as New Delhi. Summer is overall quite moderate. Maybe we may get 3 or 4 days over 40 degrees or so, not more than that. So it's a good climate, nice part of the world to live in. So, okay. So after finish my PhD, I actually got a, I was offered a faculty position for the City University of New York. And in those days, AI, and let's not stop talking more about AI. AI was, so this is I completed my PhD in 1997, which is now 24 years ago. In those days, AI, by the way, is nothing new, right? It has been around for more than 50 years. It's a discipline which has grown and evolved with people trying to build more and more advanced automation and computer systems to try to get closer and closer to the way the human brain actually works. That is AI, artificial intelligence. Now, in the 80s, in the 90s, and research in AI and development has been an ongoing process. The issues have been in the past why AI never came out into the mainstream is because of the enormous computational power required by AI, which in those days only supercomputers had the capability of conversion handling that kind of computational load. And supercomputers were enormously expensive. An average an average enterprise or a government enterprise or even a commercial organization, the servers in their data centers would struggle, or AI algorithms would take weeks or even months to converge. So when I completed my AI, I had to run. My supervisor told me you would have to probably run a year of experiments with your data and your simulations. So I said, no, I don't have. I don't have that time because at the end of it, I had a job offer in the United States. City University of New York offered me a position to head up their robotics lab. That's another story. In the end, I ended up not going to New York and refusing that job. That's another story. But what happened at that stage is that I was able to organize a parallel, processing. So in other words, we kind of simulated what's a supercomputer, enormous parallel computing. So we ran 3 servers and in 1/3 of the time. So those experiments were completed in 4 months instead of 1 year. And I published my thesis, got my PhD in that field. And ever since then, I've had a very, very, very active interest in AI for a long time. But AI, once I agreed not to go into academia. There was no AI in industry as there is today. This is only the result of, the last 4 years, 5 years, around 2015, 2016. That is because today the average server, the average industry server actually does have that amount of grunt and that amount of capability. So what would take, days or months or weeks to process now can actually convert, those algorithms can converge on an average, backend server. You do not even need GPUs. In probably in a few seconds or at the most minutes, depending on how computationally heavy those algorithms are and how much data they're using to train and so forth. So that's where the whole excitement of AI. And lo and behold, the whole world is now moving very, very strongly towards adopting AI, because with the power of AI, you can solve problems in a way that and with an accuracy that was not possible with earlier methods. But having said so, AI is fairly complex. AI needs a lot of knowledge. AI algorithms, AI projects are not exactly run in the same way as the normal standard IT project or software project. So even though the power of the computational power is there, there's a lot of skill. So in that way, I'd say the world of AI projects at the moment. Arup just described some applications. There's hundreds, literally hundreds of use cases across all the industry verticals today, and we'll go into a little bit of that. And I will present, some of our our focus areas in Turing Point in that regard. So there are a lot, but the challenges are to do an accurate job to produce a project outcome that really meets the need of that particular industry. Some AI projects, they do not end up providing the outcome. That's because this whole area needs to mature a little bit more. So let me now just fire up some of my the slides that I have here for you guys. Can people see?
Yes.
Excellent. All right. So, all right. So Turing Point, as Arup said, yes, I was founded the company. Turing Point, we founded this company in 2004. So we have been around for a little while. It was founded originally just, to provide various kinds of, upper-end IT consulting services around project management, architecture, and more recently, organizational change management. But we started looking at data analytics. So, I mean, analytics sort of took off across the world from around because people increasingly organizations started realizing that how important the data is. The whole profession of data science is probably not even 15 years old. So from around 2012 onwards, I'd say, data science and, so addressing, because the internet is a huge generator of data, big data, the whole big data revolution, and, algorithms like MapReduce, products like Hadoop, and now more recently products like Spark, all the enormous amount of big data generated by, various internet platforms, initially emails, and now, text messages, social media, data is just exploding. So, and from that data on the back from analytics, which basically a lot of it is basically statistical algorithms, the next step was, of course, AI. So we, because of our background in AI, I have a relatively small but growing team in Turing Point, and so from the name, you may ask why Turing Point. Does anybody know? Can anybody tell me who Turing was? If anyone's got a computer science background, you should know. Can anyone answer that? No? Okay.
Alumni, you should know that.
Okay.
Okay. You
all
explain.
right.
You think that you explain them. Then. Okay.
Okay, that's fine. Okay, so Alan Turing. Alan Turing was is basically regarded as both the father of computer science and AI. He was a mathematician in Cambridge in the last century, probably. He passed away. If anybody has seen a movie which came out about
Imitation Game.
Imitation Game, yes, you've seen that, right?
Yes, sir.
You've seen the Imitation Game. So Alan Turing actually defined what I mean. He actually defined. It was in a paper he published in a journal called in 1950 called Computational Machinery. And a lot of people, you may have wondered when you watch the movie, because the movie was more about how he cracked the Enigma code, which caused, because he was a mathematician, right? He cracked the Enigma code, which caused the Allies to defeat the Germans in the Second World War. So that was the focus of that movie, which was obviously a piece of text written by someone. But Alan Turing is also the father of artificial intelligence, who has something called the Turing Test. And the way he defines artificial intelligence is a machine is called intelligent based on how well it can imitate human reasoning. So ideally, the Turing test is if you have two entities and you can ask questions, you don't know, one is a human being, one is a machine, and you can't determine which is which by asking questions. You ask the same kind of text questions, you get replies, and you can't distinguish one from the other. Then and only then is the machine intelligent. Otherwise, if you can distinguish this is the machine, this is the man, then that machine is not intelligent. It is a machine. So in other words, artificial intelligence or intelligence, machine intelligence is defined by the degree, how well machine can imitate a human being in reasoning, in communication, all that kind of stuff. So that's the Turing test. A lot of so-called AI systems built today, they actually fail the Turing test. So to give you an example of a Turing test from everyday life that we all face, I am sure you would be familiar with the concept of the CAPTCHA, CAPTCHA. Can anyone tell me what is a CAPTCHA? You know, when you fill in a form and you submit it.
Actually, it comes during the Google search or any website visit.
Well, correct. So you're asked to look at some letters or some numbers, a combination, and then you use and it's sort of written in a bit of a not very clearly defined, and then you've got to type in characters looking at it, and
Yes,
they take, and then they see that, okay, you're a human being, you're not a robot. So a true AI system, when you do a CAPTCHA, a machine would be able to do it. Easier said than done. Most AI systems do not fail. So anyway, that's Turing test. So the company, the background, the name of the company named after Alan Turing. It's in honor of the guru, basically. So that's what why Turing Point. All right, now. So this is basically what this presentation will probably just only take another 10 minutes or so, and then we can be open for discussion and questions and so forth, both Arup and I. So what this is, this is a talk which I think now more than a year ago. I was invited as the speaker. I presented to an organization known as the Service Science Society of Australia. It's one of these, in Australia now, Sydney is very vibrant. We have a lot of startup enterprises, and there's a rapidly evolving ecosystem of innovation, very similar, obviously not, we haven't been in it for so long as the Americans have. So, but there is another Silicon Valley growing here very fast. And there is an organization called the Service Science Society of Australia, which is basically a collaboration forum between academics and commercial organizations, advanced commercial organizations. But that's in what is service science? I'll talk a little bit about service science as well. So this talk that was a 1-hour lecture which I gave, and these slides were actually presented. Some of this stuff was actually presented there. So we are calling leveraging AI for improved service productivity and business outcomes. So that's what essentially is our aim and objective in Turing Point. Now, what we are introducing here is the concept of AI as a service. So what do we mean by service in the broader economic sense today in the world of business? Service, okay. Traditionally, economics has been is basically how do countries improve their economy? How does economics? So traditionally, it has been more about exchange of goods, exchange of products. But in more recent years, people have come out with more thinking. It's not only trading of selling and buying and selling of products, of goods that enhances economy. There is more. There is a more intangible element, depending on building relationship, developing confidence in people, and overall providing it's a service. So even the goods and products are actually included under that bigger mantle of service. So this is from a paper published by Larsen Vargo, and it's called The Service Dominant Logic of Marketing. And where they define service as the application of specialized competencies. This is quite broad in general, but specialized competencies, which is knowledge and skills through deeds, processes, and performances for the benefit of either another entity or the entity itself. So, an organization, you can also provide services to your own organization to make it more efficient and more skillful. So service can be does not necessarily always have to be to present it to a third party. But I mean that's the general definition. Turing Point. We have we are progressing opportunities of providing AI as a service to address and resolve multifarious problems in any business domain where sufficient data is available to train an AI learning agent. So that is basically the key thing that we mine. I think everyone's heard of this term data mining. So today, data mining is a bit of an old-fashioned term, but essentially that is what we do with AI. If you don't have data, then with very little data, you cannot do a great deal with AI. You do need data, but dealing with data, just the data engineering part itself is challenging, and then you need the right AI. So these are not easy projects to do, but if you do them well, then the amount of value that you can add and the kind of problems you can solve is enormous. So we'll go a little bit more into that. So, but multifarious problems. So in any business domain, really. So the skills you need skills in the primary skills we need are data engineer skills, data scientist, data engineer skills, and AI skills in AI, which are quite specialized. So AI is a service today. I mean, there's many things which in IT now are they have the term as a service, the cloud model, which we're all familiar with. You have infrastructure as a service, you have platform as a service, you have software as a service. Here, we are saying we are providing you with AI as a service. Now, AI as a service, what is it? It consists of the deployment of advanced algorithms that discern the relationships and structure in real-world data, i.e. learn from past business experience, and are able to use that learning to indicate the expected outcome or a targeted, the expected outcome for targeted or anticipated business scenarios. So let me explain that a little bit more. So today, in a very, very fiercely competitive area of disruptive technologies and new digital business models, every business, at the end of the day, what are they they're targeted towards? Number one, higher efficiencies, two, greater throughput, three, reduced operational cost and weightage, reduced risk, enhanced safety and security. So AI as a service database paradigm can be used both for anticipated as well as for targeted business outcomes. Let me try to make that a little bit clearer by an example. Now, a simple one. You've undertaken a project, bricks and mortar, you're building a house. Now, there's when you build a house, you need you need bricks, you need sand and cement to develop your concrete. You need paint, you need wood and metal, for the windows, for the doors. You need and you need labor. You need various machines to dig foundations, to move the material, to set it all up, and then you need to install the electrical wiring, the plumbing, all bits and pieces. So there are so many components. So it's a significant engineering exercise. So when you do that, if you were able to predict and plan exactly how many bricks you would need to order without wasting any or minimizing the waste and every other component like that, you were able to schedule exactly how many people you would need or which skill set. So it could be a bricklayer, could be a mason, could be a plumber, could be an electrician. There are so many different tradesmen and you need and technicians just to construct a building or a house. But how do you roster them? How do you pay them? How do you manage the cost? Usually, these projects, they're planned and so forth, but there is quite, and some of the, and they do use various scheduling techniques to try to plan and minimize wastage. But with AI algorithms, if you actually plan, if you address a kind of, a whole business exercise like that, you can minimize wastage. You can have high frequencies. You can deliver in a much more predictable time frame. So overall, reduced risk and also, safety and security. I'll come into that a bit later for various operations. So your throughput and your efficiency and your cost and wastage is minimal. More and maximize throughput, maximize efficiency, and minimize operational cost and wastage. So that's those are basically the kind of the results that we would offer in providing AI as a service. That makes sense. So predictive analytics, anticipated outcomes, and control, targeted outcomes of industrial business processes. All right, so improve service productivity. So here, I'll just quickly go through some of these use cases. I mean, this for this purpose, this talk. This is not really a technical session. This is we will not go into any of the details of the kind of AI. That's a topic for much more specialized and a much bigger and session, possibly for a different audience. But here are some of the we've just covered some of the well-known industrial verticals, as they say, and these are just some examples of standard problems that we can solve, or use cases as we call them, business scenarios, whatever you want to call them, where AI can add value. We're not saying that we are the only people who are offering this. These are use cases where people are already looking at solving them, but how successful they are is a bit of a question mark at the moment. And these are not the only use cases in these areas. There's many others, but these are just some of the standard ones, just to give you a feel. So in the agriculture industry, now Australia was originally, the primary industries in Australia are still agriculture and mining, and India is a bit like that too. India is primarily agricultural, and there's quite a lot of mining in India too. So, okay, classifying patterns from visual sensor data. Yeah, visual sensors, as you know today, are cameras on fruit, vegetable, plant produce for contamination, quality control, enhancing efficiency of market-ready production, minimizing the huge losses due to contamination. The next one, optimal control of agricultural machinery. This is out on the cultivation on a farm. So machinery such as tractors, crushers, threshers, etc. If such machinery is fitted with appropriate sensors to obtain their performance measures such as speed, load, throughput rate. Basically, that is the data you collect. And then you feed it into an algorithm, and it comes, and you design it in a way that it helps you to provide that optimal level of control to get your throughput and efficiency. Okay, let's move on. Finance, just a couple of things there. Credit risk of loan applicants in banks, rating insurance risk levels of underwriting policies. AI has been used for a long time for insurance risk levels, underwriting, and so forth, but those have been rule-based AI. Today we have much more advanced techniques like deep learning. Moving across to the next one. Okay, mining. I talked about mining a bit earlier. Here are a few use cases. I won't go into each and every one of them in detail, but optimal control of mining operations and adaptive control. Optimal control, adaptive control are slightly different. In some ways, they're similar, but adaptive control is when you're adapting to changes in your system over long time. And optimal control is basically you're designing a system where you provide the optimal outcome that you want from that particular system. Safety, that's a big one. Monitoring data combinations, map them to earlier recorded levels of safety, including alarm conditions and emergencies. And you can you can trade an AI system on that data. This can actually be superior to those provided by traditional modeling methods, reduction of risk in new mining prospect exploration. So this is another one, drill data. When you're drilling for a new mining prospect, you don't know whether once you dig 1,000 feet, whether you'll actually strike gold or not. So that's done in degrees, and traditionally that's done by relying on the geological, the knowledge of the geologist after they dig up, the soil and take it to the lab. But if you train an AI agent on that sort of data, then if you later and then you're drilling, your data prospects are analyzed in collaboration with a human expert and AI, and AI is the system and a human expert together. You have a much more powerful and or more reliable prediction of the drilling prospect, because as we know, a lot of mining prospects, when they dig, they spend hundreds of millions of dollars, and then it comes nowhere. So it's a huge risk. So you want to reduce that risk. So in other words, these solutions will result in the saving of hundreds of millions of dollars for a large mining enterprise. So it's very powerful. More use cases. Okay, manufacturing, that's a very general one. Optimal control, or because manufacturing is huge, there's, manufacturing covers so many different kinds of manufacturing, but optimal control, I mentioned optimal control earlier. You want to produce the optimal control. Optimal control is whatever optimal means. It's basically the best desired for whoever is applying using that system. It's the most beneficial to the user. That's optimal. Optimal control of automated manufacturing plants. Input and output parameters are measured. So that's basically the data. There are some very, very specific AI algorithms which can give you that kind of optimal control, which other previous techniques in optimal control, from standard control theory, this is more accurate and more reliable. Transport, railways, airlines, So I think Arup just mentioned railways. So I think scheduling of just trains and flights and the staff rosters around those operations, a very, very data intensive, huge problem to do that in an accurate way. So that can be done, more accurately with AI. Enhancement of safety by triggering alarms where relevant parameters are measured and historical data is obtained. Overall corporate performance, predicting employee and sales performance within a large corporation by training an AI agent on past and relevant enterprise data. Okay, so I think we're coming now to the end of these use cases. So in general, the more data is available, the better the performance of an AI agent, and you can retrain the agent by methods such as there's methods such as reinforcement learning and so forth, where with experience, your AI agent gets better and more reliable over time. So it's continued. There are paradigms like continuous learning. And in the digital industrial scenario, such data can actually be collected today. Sensors are everywhere. Sensors are prolific. Sensors are cheap. So data can be collected by sensors connecting various industrial devices to the internet. We all know of IoT today. Already, there are more than 50 billion devices connected to the internet. So you can see that what the overall scope is. The predictive analytics from big data emanating from IoT, it saves enormous industrial operational costs. And this combination of digital techniques is today called, you may have heard, it's called the industrial internet. So there's a diagram, and I think this is my last slide. What is the industrial internet? It's the convergence of all global industries, sectors with processing and making sense of data and analytics, more sensors at a low cost, universally standard industrial platforms like big data, IoT, all combined. What is the result? Up to $15 trillion of increase in global GDP over the next 20 years, stemming from smarter decisions, optimized performance, substantial savings in fuel and energy, and higher productivity. So the value add is huge. It's absolutely enormous. Okay, I think I'm going to stop there, and yeah, back to the chairperson, and happy to discuss further if you have any questions for me. Let me stop presenting that. Okay, back to you, Mr. Chairman.
Dr. Shivendu.
Hello. Hello, can you hear me?
Yes, yeah,
Yes,
I can hear you.
We can hear you.
Okay, thank you, sir. And I request our student to interact. I think you have many queries.
There is a, I think, hand raised from Anwar's side.
And I don't know whether she is having now a lab exam or not. Deepani, just check it. Where is Onkita? She was there a few minutes back. So otherwise, you tell her to post the question, her query, so that he can.
we can take
Anwar. Actually, Viva going on actually.
All right. Okay, understood.
Yeah.
Okay. Anwar, carry on your
I have
questions,
one
please.
question.
Yeah.
And another thing, I like to introduce here the Ombika Vishwas Nela. So she's from Bangladesh.
Oh, hello, Ambika.
Hello, Ambika.
Hello.
Hello.
She's from electrical, no? Ombika, you are from electrical, no?
Yes, sir. I'm from electrical engineering.
Oh, fantastic. So, which part of Bangladesh you are? My ancestor from Bangladesh too, from Chittagong.
I'm from Mymensingh.
Oh, okay. I've been there actually. Very good place.
Okay.
Good to hear that. Okay, Anwar, please place your question.
Yes. Hello, everyone. Okay. So there is a project that I'm working on. That there is a smart bag. Like I'm creating a smart bag. Like that can provide this feature that the bag will automatically add necessary items that the consumer may buy from his past purchases. And I am good at developing web applications, but not very good at embedding AI or some these kinds of APIs things that behave like that can be embedded into my project. So can you provide me a little help? Like, are there any cloud solutions to it? Where can I look for it?
Let me just understand. Let me understand the application a little bit better, and then I'm sure I can make a suggestion. So you're calling a smart bag? Did you say BAG?
Yes, sir.
A smart bag. So well, what is it? Is it a shopping? Is it a shopping bag?
Yeah,
Yes,
like it will be a bag just like a cart in a shopping website.
Yeah.
Yeah.
Sure, got you. So it's a smart bag, and so you're obviously making you would like to have it an ability to basically understand the patterns, the shopping patterns of each customer.
Yes,
and
sir.
then based on those patterns, then suggest and predict, other things that they should buy. But where is your okay? So yes, there's definitely methods of doing that. I mean, it's very popular. You can see everywhere. I think most of the advanced sites, and Google are full of AI everywhere, as you know. You'll probably see that if you go to there are certain sites that you search and you visit more often, you'll see those will pop up more on the side when you next time you do Google search. I'm sure we've all noticed it. Or you go to YouTube and there are videos that you watch on certain subjects, and that's your area of interest. The next time you go to YouTube, you'll have more of those popping up right to your front end. So that's very, very typical. It's AI which does that. So you want something similar for your bag. Is that right?
Yes, sir. Exactly.
Yeah. Certainly, we can. I mean, there are methods. There are
then suggest that Anwar, if you can just communicate with us, probably we can guide you through for that, for some where you can find out the related materials from Dr. Tirthankar or myself to carry your project to the next level. Is that probably not? I got your all information. Will provide you after the discussion. Will provide our both email ID so you can correspondence with us. Is that okay, Anwar?
Yes, thank you, sir. Thank you.
Sir, I am Chandima. I also like to have guidance over this matter. I am also looking forward to this project. It's part of challenge actually.
Right.
Okay.
Okay. So is it a project that you're doing for your degree, for college, or is it more an industrial project? What are we doing here?
Industrial project, sir.
Okay. So so it's an industrial project and it's being done for you're doing it for a company?
Yes, sir.
Right.
So,
Okay.
okay.
So Arup, I think we need to
We need to
probably
yeah.
discuss that one offline.
Offline. Yeah. We'll do.
Offline, because the thing is, we are we are not an academic organization. We are not a consulting organization. We are a commercial organization. So we provide industrial guidance, but we are not. We are not here to provide academic guidance here. It's and our intellectual property is protected for commercial reasons, because our expertise, we sell our stuff, we make money out of it, and therefore anybody who works with us as well. So there should be what we have to avoid is a conflict of interest.
Yeah. Can I just put in more into? We are currently working with the college right now. We propose them. Once everything we have agreed both, then probably we'll go to that level. But at this point, definitely, you can, like anybody, if you want to contact with us, we are more than would like to help you. But just until we'll sign off with the college, we are not ready to give you that level, how can I say it, like a guidance to further and take you to the project, whatever, because as Dr. Tirthankar already mentioned what our like skill sets and where we're standing right now. Is that okay?
Yeah, because just to make that a little more clear, if it's for just for your academic project, for an assignment that you're doing for your college, for your degree, and so forth, I mean, I don't mind helping. But if you're actually doing it for another company, for another industry, so that's a commercial interest, making money out of it, then that's a different story, right? Yeah. So because we are a commercial organization.
Yeah, it's a conflict of interest.
There's a conflict.
Exactly right. Yeah. Okay. Next question. Hello.
If you have more questions, you can send them across. You have our contact details.
Hello.
Contact. Yes.
Yep.
Yes.
Hello. I'm Sudipto Mukhopadhyay.
Hello, Sudipto.
I'm from IIT Kharagpur. I got actually the information about this talk from one of the alumni of NIT Durgapur. And we are working in actually image processing and a little bit of AI. And we have some patented solution for a real-time rain and fog removal. And we are looking for the technology transition of that. And it's great to see that both of you started from academia, and you have actually made it possible to apply the technology in the industry. So if you can help in some way and in commercial terms, that would be great.
So you've developed some. You have developed some intellectual property which you would like to commercialize. Is that how I read it?
Yeah. I think you are perfectly right. And if I get your contact, then I can send you some actually more information about that, and we can take it offline.
Yeah, thank you. Absolutely. We'll provide here.
Absolutely. Yeah. So our contact details. I think they should be available. Can you post it? I can't see.
If you can post it.
Yeah, my chat seems to be disabled on this one for some reason. It's grayed out. I can't post anything in the chat. Arup, can you?
Just looking at right now. Shivendu, you there?
Hello.
Yeah, Shivendu, we can't post anything in the chat room actually.
So, Anwar, your hands
probably
is on. Anwar. Okay.
So, but
So,
otherwise,
any other question from the participant or audience? Hello.
Yeah, but the kind of question we just had just now from the gentleman from IIT Kharagpur, that is exactly the sort of thing we would like to look for, moving forward. We would like to work with academics and academics and students and research groups who have some some background in this area, who would jointly work in collaboration with us.
Can I just, if I tell to if the gentleman, I forget the gentleman name. What's your name, sir?
I'm Sudipto Mukhopadhyay.
Yeah, Sudipto.
I was also looking for that how to post my email address or that.
That's okay. Can you write it down? Our email ID. It's Arup,
just a minute.
ARUP.
Just a minute. ARUP
at
Turing
Point, TURING.
Turing Point.
Turing
is hyphen there.
Point.
Okay.
Hyphen point. Yeah. .com. And
so,
then
Arup at turingpoint.com or Tirthankar at turingpoint.com. TIRTHANKAR.
Correct.
At turingpoint.com. So turing-point.com. So those are our email addresses.
Email ID.
You can.
Thank you, sir.
So I don't think any. Yeah. Any questions?
I think someone was.
Hello.
Sorry, we cannot hear you very clearly. I think
Shivendu?
the disturbed line. Can we sort of get a little bit more clarity? I think someone was talking, but we couldn't quite hear.
Hello.
Yes, we can hear you, Shivendu.
I like to know here. Now today is the era of Industry 4.0. So it's basically multidisciplinary. Can you hear me?
Yes, we can hear you.
And there
Industry
are
4.0, yes.
Industry 4.0, there are many ingredients or many components there, like IoT, big data, that robotics, additive manufacturing, cloud computing. So which way that a non-computer science guys can cope up with this? Do you have any? You can give some light on that, so that because in this particular group, many students who are other than computer science electronics. There are the metallurgy. Some students are from the metallurgy, some from the mechanical. So for them, because ultimately AI for industry means any kind of industry. So which particular knowledge base or which particular skill is required to cope up with this such a modern technology?
Very good question.
Very good question. Let me try and answer that one for you. Okay, so as you probably, you heard from my presentation, one of the key things there is data and information, right? So in every industry there is specialized data, and when we do an AI project, one of in the sort of team we always need the business domain expert. So if there's somebody, okay, you are running, you're doing an AI project to optimize the performance of a metal extraction process, for example. You have metallurgical engineers there who really understand that process. So that knowledge, that data is something which your data scientist, he understands the data. He can, if you tell him this is the data, this is the outcome, but he doesn't, all he sees it as often as a black box, and there's input data, output coming out. But what do you want to optimize? What are the elements that what's the throughput? What's the yield that want you maximize? It's the local, it's the guy who actually has that specialized knowledge of that particular industry domain, who will be able to help you. So you always need those guys. And when they actually work in collaboration with a team like that, that's how they can get into the field, essentially to get on to become more knowledgeable about AI. I think most people who study engineering degrees today, there's a certain element of mathematics that you do. Would I be right? You who would certainly do things like, linear advanced algebra. You do things like, matrices and linear, nonlinear equations. You do multivariable calculus. Irrespective of your branch of engineering, do you guys do those courses for your students?
That's there. Even they are also learning the linear programming as well as the goal programming, this game theory. So that is also there. This kind of simple optimization techniques also included in the mathematics syllabus in undergraduate.
Okay. Okay. So with that background, they should be able to pick up. And the other part is data, right? Is big data. So big data, I mean, traditionally databases and data modeling, data engineering from the computer science background, that's basically database theory, relational database theory, which is basically the basic mathematics from there is relational algebra and sets. So set theory, I think we all learn as engineers, or whatever maths we do. I don't know, maybe even year 12 you learn set theory nowadays. So I don't know, I've been, away from the high school scenario now for a very long time. So, but those are the basic building blocks. But what they found is, that relational database paradigm is, it's not powerful enough. It cannot cope with the volume of data that is generated today, the 3 V's, volume, velocity, and variety. So they come out with a different paradigm called big data, which is basically nothing, because you have so many different fields in big data. So what they do is they use a map reduce. So it's a kind of mapping to from a higher dimensional space into a lower dimensional space, and then that's kind of managed a little bit more that way. I mean, that's the basic philosophy of it. Of course, it's a lot more complex than that. So big data, if you have so I'd say a little bit of a background in database theory, which I think if you have the right math, you can pick up on those quite easily. I think most people learn some kind of programming nowadays, right? Irrespective of your branch of engineering, do you learn to do some coding? Or at least
that is mandatory for all discipline. So it has been taught in the first year itself. Even it has been taught in school level.
Okay, so there you go.
That's very,
but the idea of the algorithm, the basic algorithm concept, even if it's in a flowchart form. The idea of an algorithm, the logical reasoning, the loops, and so forth. If people have that kind of background, and then they get, most organizations are investing in some kind of AI project nowadays. So I would encourage people with that sort of background, if you are working for an organization where your field is specialized. You can be a chemical engineer, you can be a metallurgical engineer, you could be a mechanical engineer, but there's some AI projects going. You have the data domain and knowledge and experience. You can you can put your hand up, you can get involved with an AI project, work with those guys, then that's probably the best way to pick up a bit of background study. But if you don't have that mathematical background, like in Australia, we do have, in the Western world, you have a lot of people with those issues. There's people in IT who are coders, but they don't have the mathematical background, so they really struggle to understand AI. But I think, in India, it's a bit better. People, the average mathematical grounding of students from Indian universities and the good engineering colleges is actually quite good. So I think you have a much better chance of getting on top of it. Does that help? Does that answer?
Hello.
Yeah.
So
I just want to
most of the Indian university that we Indian are strong in mathematics.
Mm-hmm.
Mathematics, absolutely. So that's, yeah. And Shivendu, just one more thing, I just want to add what Dr. Tirthankar Ray mentioned. Look, this industry, next 20 years is a $15 trillion industry. So means the today the students who just graduating, that means the bright future for them to involve with any, no matter whatever because data is the big, like it's expensive than gold right now. Any source of data, no matter what industry it is, already Tirthankar mentions in his presentation. So just encourage is every branches, the no matter what discipline they're studying right now, encourage them to involve with, to deal with the data, day-to-day things. So definitely any industry they can flourish, because it's the next 20 to 40 years is going to be biggest industry for the AI and the big data concept.
Yes, it's set to, it's set to grow. Every large organization across the world, whether it's a bank or whether it's a big manufacturing house, whether it's a massive retail organization like an Amazon or a Walmart, they're all focused. Yeah. They're spending hundreds of millions of dollars on data projects, and each of these organizations they have a chief data officer. And the whole thing is about managing data and looking and using the data to improve your operations.
Wisely.
Yes, exactly. Say for example, the banking industry today. Banks are not the banking operation today. It's not about money or it's not about cash. Cash is virtually disappearing. What does a bank do really? It's you just move data around from one one data repository to another. It's all done with IT and software. So if you look at it, banking operations are nothing but data operations. So those can be made more efficient with, there's a lot of financial fraud around. The other big area is cybersecurity. There's so much of cyber theft and cyber crimes, and to make your organization, to prevent yourself from being hacked. There's more money stolen through cybercrime today than by any other form of theft. To protect against that sort of thing. Cybersecurity is a big area, and today this is relatively new, but application of AI to cybersecurity to make your encryption more powerful. It's a big area of opportunity.
True. Yeah. All right.
Another thing I like to know, because we are in our NIT Durgapur, many faculties working in the area of your fuzzy logic, artificial neural network, and the different hybridization of that, like adaptive neurofuzzy inference systems, and also the biologically inspired meta-heuristic optimization algorithm, like genetic algorithm, evolutionary computation, particle swarm optimization, like that type of work we are doing in a computer science, electrical, mechanical, in each discipline. So I like to know how important these particular tools, this is also computational intelligence tools in respect of the industry, or in respect of the talking about now.
Well, the ones that you described, that we do all those things, right? Where deep learning, neural nets, and there's so many neural net paradigms, RNNs, LSTMs. They're very powerful today. Fuzzy logic has been around for a long time. I mean, fuzzy logic, I guess it's kind of AI control theory. But fuzzy logic is used has been patented for a long time. I think most of the better washing machines are all, they
all
have
run by
fuzzy logic controllers. But neural nets, deep learning. But, there are challenges to really do deep learning properly, because deep learning has its challenges. You have if you worked in deep learning, there's the bias variance problem. And if your data is too biased and you've trained it, then your outcome, the deep learning model, your accuracy would be a bit questionable. But those the areas that you just mentioned, and also unsupervised learning, clustering methods, genetic algorithms. I talked about optimization some time ago. Genetic algorithms are basically a very strong, very, very computationally expensive. They're very heavy on on your CPU, but yeah, yes, genetic algorithms are a very, very strong optimization tool, and the hybrid methods that you mentioned, neural, fuzzy, and so forth. Yeah, at Turing Point, we've actually developed a number of our own algorithms to address some of the problem application areas that we went through. So hopefully that gives you an insight. So if you've got people with those interests, some of that knowledge, skill sets, then absolutely, that is what's needed. The thing is, there are a lot of open source tools as well around in the market that people can use. They're quite good. The most popular development, the coding platform there, as we know, is Python. So I don't know, are students mostly learning to code in Python nowadays instead of the earlier ones like Java?
Many students are now using Python for coding such type of algorithm in our institute.
That's good. That's good, because most AI work today is all done in Python. All the development platforms, they're all basically all Python based. So that's definitely the one of choice. And more, the whole all the whole Western world, in terms of IT skills and in terms of supplementing or complementing the IT capabilities of an organization, people are looking more and more towards India. Already there's so much outsourced to India, and I see that as a growing trend. And I see there's a very bright future for our for our students. Today's students are basically the industrialists of tomorrow.
Correct.
So, yeah.
Yep. All right.
Yeah. So we are very, very much in sync with you guys.
In chat box, is there any questions, Deepan?
Yeah, I couldn't see the chat box. I think it's disabled for us.
I've seen one pop up. Deepan,
Yes,
you check it whether is there any questions in chat box. And before that, I request Sukriti. She's present here. She's working in image processing for industrial automation kind of things.
Okay.
Have you any query?
Hello, Sukriti.
Hello. Yes, good evening, sir.
Good evening. How are you?
Good evening.
So here is they talk about the AI and the image processing in the industry. Can you do you have any query on that?
Yes, sir. Actually, the my topic for that project that I'm doing is on automatic color detection of fuses and automatic fault detection of fuses. So I'm basically using object detection techniques for that. So presently, sir, I was going through all the object detection techniques that we are having, like RCNN, faster RCNN, YOLO, and SSD. So we like comparing the pros and cons of all the object detection techniques. So, sir, can you please suggest that, like, which would be the best technique among them? Or can I combine one or two techniques together to get a better, like both in time efficiency as well as accuracy?
There's a lot of combination and hybrid techniques around that you can use. But let me just try to understand the application a little bit better. You said object detection?
Yes, sir.
Okay, for what? For what kind of objects? So what's the industrial domain, please, that you're working in?
Sir, actually, like from a fuse box, using artificial intelligence automatically like detecting which are the fuses and what is the color of the fuse or what is the ampere rating of the fuse. So like
actually electrical fuse.
Okay, fuses.
Oh, fuse.
So this is okay. So
fuse.
this is
the fuse boxes that are installed in the automobiles. Actually, they are present in the dashboard. So like it's not easy to like reach them at the time when the fuse box is already installed in the automobile. So this part, like so the detection part is done in the factory itself, then it would like decrease a lot of workload.
Yeah. Okay. So, this is the car, the automobile industry, the electricals of an automobile.
Yes, sir.
Okay. So the electrical system of an automobile, which today can be quite complex, and there's increasingly now cars are fitted with more and more sensors, and with that sensory data, the really more advanced, vehicles, the more expensive ones, I think they have some AI inbuilt as well. Okay, so this is basically AI. So what are we detecting if there's, the chance of a short circuit and that kind of stuff? Is that what you're looking for?
Yes.
Those. So short circuit, and I mean basically because I studied in electrical engineering, I have a little bit of background there. So you're talking about the safety, the fuses, the circuit breaking, that sort of stuff. To have that,
if the fuse is like blown or not, like we can use contour detection for that. So I have done a bit of the project, and I've almost completed the project. But like right now we are working on the efficiency part, like which technique or which like AI model to use to get the most efficient model.
Yes, but what it depends on how you define efficiency. What do you what are the parameters that you want to max? So when you do efficiency, there are certain parameters, output parameters. You define it. You basically will define your model, and that's the difficult part. What are the inputs that you have control over? What are the inputs that you want to minimize, and what are the inputs you want to maximize? And then once you can define that, then you gather your data, and you can do that. You can train a deep learning model to do that essentially at a high level. I think that is your answer. But you need to go into details as to exactly what are those parameters, what are you measuring, what data you can collect and feed into your model.
So actually, like the fuse box will be passing on the conveyor belt, and like a camera will be installed on the top, and it will be it will be a bird view camera. So it will be taking an image as the fuse box passes, and at that moment itself, it will be taking the image, and it will be detecting the fuses, which fuses are installed, what is the ampere rating of the fuses, so that we don't to prevent a short circuit from happening at that point. So basically the parameters that we are concerned about will be the efficiency, that is the time efficiency. It should minimize the time taken to run the model, and it should increase the accuracy. Like right now we are on an accuracy of 96%. So if it would be at least 99%, so that we can present the model for some future purpose also.
So what's the model that you're running? What are you using for which has got 96% accuracy?
Yes, sir. So presently I'm using YOLO to do the object detection part, and then I've used Python is the main language that I've used behind everything.
So what did you say? YOLO?
Yes, sir.
Okay. So that's and you're collecting. So you're using YOLO. Okay. So that's real-time object detection, right?
Yes, sir. It is a deep learning. It includes the darknet part, training using the darknet.
Okay, and what are you doing? Okay, you're doing it in darknet. Fine. Okay, and
yes.
that's do you use TensorFlow?
Yes, sir. I use TensorFlow, but
Sorry, you dropped out a bit.
Hello, dropped out. Yeah. Shukriti.
All right,
Okay,
let's. I think let's take this offline, right? Happy
offline,
to chat offline. Yeah. It's an interesting application.
Shivendu. Yeah, it is. Yeah. Shukriti.
Yes, sir.
Yeah. Can you write it down our contact email ID? You can offline send the request to us. We will help you there. Okay.
Okay, sir. Okay, sir.
So, all right. I think this is at 10 p.m. in Sydney now. And again, I'm gonna thank you to Chairperson Dr. Shivendu Roy, and also all my alumni for giving us this platform this evening. And of course, thank you to Dr. Tirthankar Raychaudhari to come along with me tonight.
It's been a pleasure.
And thank you, Shivendu.
Just 2 minutes. 2 minutes that from the student side, they like to present something and vote of thanks for. It will take hardly 2 minutes.
Sure.
Okay.
Go for it.
Before that, you like to say something?
No.
Yes. So if you can,
so Arup, do you have anything to say?
Shivendu, yeah, I just want to share, Shivendu. Please, we are, as I said, I'm already coordinating with the head of the computer science engineering department right now. So hopefully, if something is come smoothly, when you sign off our NDA with RSC NIT Durgapur, then obviously we'll come with our proposal.
Okay, sure.
How we can help our alumni, everybody. Yeah. So we'll come back again, definitely, Shivendu. And in the meantime, if you can share our contact email ID to all alumni. So if anyone needs anything AI related, they're more than happy to ask any questions through the offline.
Okay. Thank you. So for the student, I like to clarify that one. That our alumni we like to create one industry institute interaction program through the non-disclosure agreement sign as well as the memorandum of understanding with NIT Durgapur.
Yes.
And from the institute side, there are a few faculty members. They are the mentor. They have to sign that thing. Confidentiality. This has to be signed. And recently, Arup Dutta contacted with the HOD Computer Science as well as our professor Dr. Tondrapal in this regard,
Yes.
because they are the right person in the area of artificial intelligence. And irrespective of the branch, the student who are interested in this particular field, they may contact with the ma'am and the HOD Computer Science for this type of industry-oriented projects in the area of artificial intelligence.
Correct. Excellent. Yep.
Sure.
Okay, now from the student end, like to conclude the session by please.
That's a beautiful, nice. Yeah. Thank you very much, everybody.
This is from the institute side. That is one token of appreciation or token of love, you can say, from the institute side.
Thank you.
As it is now, all are in the E form. So this is also E certificate of appreciation. We like to present.
Absolutely. It's
it was a great pleasure. Thank you so much for inviting us. It was really good talking to you guys.
Okay, now organizer, please conclude.
Thank you, sir. Bye-bye.
Thank you. Thank you, everybody.
Thank you.
Am I audible to everyone?
Yeah, we can hear you.
Yeah, thank you so much, sir. This was a great learning session. We thank you for your participation and we wish you all the best for your future endeavors, and we hope for more learning opportunities from you. Thank you so much.
Thank you very
Thank you, everybody.
Okay.
Thank you. Good night.
Good night.
All right.
Thank you very much.
All right. Good night. Good evening.